They've solved this problem by using a connector that slides back and forth on rails. This will absorb the pipe's movement and keep the gas flowing. Meanwhile, engineers are tackling the Storegga slide and trying to get the umbilical cord from the template to the control center 120 kilometers away. To do this, they have to find a way through the rough and tumble terrain left in the wake of the slide. The solution is to build an underwater excavator, agile and strong enough to handle the job. It's a daunting prospect. And the answer is a spider. The machine that inspired this one was originally built for the Swiss forest industry. Like its Swiss cousin, this spider moves on powered tracks using articulated legs. Its mission is to excavate 6 trenches at depths of up to 1,000 meters. The biggest trench will be 4 meters wide by 4 meters deep. One spider is equipped with a powerful shovel, strong enough to cast aside a 3-ton boulder. The other spider has a suction nozzle. Powerful water jets break up the sea bottom, then the nozzle sucks it up and fires the mud to the side. All the while, the spiders will have to contend with slopes of up to 35 degrees. There are sensors on all movable parts connected through an umbilical from a support vessel which floats above and monitors progress. The umbilical carries power and control cables and lets operators manipulate the 6-meter-long spider to within 10 centimeters of accuracy, from 1,000 meters above. It's an unprecedented mobilization of such complicated and agile robots. In all, these 2 champion diggers managed to excavate 3,500 cubic meters of soil and create a safe path for the gas pipeline. The Langeled, which will run 1,200 kilometers from Norway to the UK, will be the largest subsea pipeline in the world. Building it requires 1/3 of the world's combined pipeline production capacity, over 1 million tons of steel. The value of the pipeline contracts is a staggering $700 million. Langeled uses pipes over 1 meter in diameter, and each single piece of pipe has to be able to withstand the enormous pressure on the sea floor for the next 40 years. The pipes are each 12 meters long and weigh 10 tons. And another 10 tons of concrete and metal is added to give them enough weight to stay on the ocean floor. A total of 100,000 steel pipes are needed to span the distance between Norway and the UK. That includes over 1 million tons of concrete and 25,000 tons of steel reinforcing. Robert Payne is the man responsible for the integrity of the pipeline as it's being assembled.
Each joint of pipe weighs about 20 tons, about 10 tons of steel, 10 tons of concrete. It's concrete and it's got inside of it a wire mesh foundation to help it stick together. There's so much volume inside of it whenever it gets on seabed and it gets light of air, it wants to float, so the concrete keeps it situated on seabed.
Each of the 100,000 pipes is numbered as it comes out of the plant and is destined for a specific location in the line. As the team trenches on the steep Storegga slide, the rest of the route from the top of the slide to shore is being prepared. This is the Island Frontier, a state-of-the-art trenching ship that combines 2 trenching methods in one powerful machine. Engineers survey the flat areas where they think they can bury the pipe by scraping a trench through the sandy bottom. But what they discover is not a pretty picture. The sandy bottom is actually clay, and the clay has hardened like concrete. A new digger is required to cut a channel up to 7 meters wide and 5 meters deep. The margin for error is only 50 centimeters on the width and a crucial 10 centimeters on the depth. The clay cutter hybrid, the only one in the world, is lowered to the seabed. The cutting tool uses 24 water jets set at different angles to blast a trench through the clay. Suspended above is the 4-ton jet prop. The propeller draws in large volumes of the surrounding seawater, driving it at a high force towards the seabed and clearing debris from the trench. Transponders mounted on the sea floor relay a 3D picture of the operations to the control ship. And following along the entire operation is an ROV that surveys the trench and confirms that it's dug to specifications. The battle is finally won. But when they start to lay the pipeline on the seabed, the problems really begin. The seabed under the North Atlantic is a tortuous, irregular landscape. And there's over 1,000 kilometers of terrain like this along the pipeline route from Norway to England. It's so rugged that only small sections of these heavyweight pipes will actually make contact with the seabed. This is called free spanning. It's something the engineers don't want because it means the unsupported sections of pipe could sag and break under their own weight, causing an environmental catastrophe. They have to find some way of flattening out the route.
If you're not able to plane the seabed flat by moving the earth out of the way, you may have to fill in some holes with rock or other fill material.
They leveled the pipeline route by laying gravel on the sea floor. This ship loads gravel into its cargo holds and delivers it to the area that needs leveling. It can carry over 9,700 tons of gravel at a time. Once at the job site, it uses a flexible fall pipe to place the gravel onto the pipe pathway. Computers create a 3D model of the seabed and the path where the gravel needs to be placed, allowing the crew to place the gravel precisely where they need it.
At these sort of water depths, you've got a problem because you haven't got that degree of control. I mean, whatever's doing the work down there is a huge distance away from the mothership, and they've got to still present a flat, smooth profile for the pipeline then to be laid upon. The other thing that has to be worried about is that you have to do that profiling as close as possible to the time that the pipeline is going to be laid, because Mother Nature tends to move things around again after you've left. And so you come back in a couple of weeks later and you find there's been a storm or whatever, and what you've taken so much care to flatten out has all of a sudden been moved around again. So you would lose the work that you've done before.
The pipe laying itself is a monstrous job. Once the pipe has been manufactured, it's placed onto supply ships for delivery to the pipe laying barge, the LB-200. The barge is longer than 2 football fields, an enormous floating steel welding factory, which has to work with military precision. There are only 3 of these ships in the world, and Hydro is using 2 of them here.
Pipeline route has been surveyed before we ever came here. We have an ROV boat that stands by with us. It monitors the pipe as it touches seabed, and it's a predetermined route that we follow.
The barge has been used in the Gulf of Mexico, in the Mediterranean, and off the coast of West Africa. But this is its biggest and most historic assignment. Once the pipe laying process starts, it can't be stopped, not even for weather or accidents. The pipeline is built as a continuous tube that's dropped from the ship to the seabed. If the ship halts for too long, the strain on the pipe could snap it. The barge moves along at 4 kilometers a day and needs a constant supply of pipe sections, which must be delivered in the order in which they're to be connected and laid down. 100,000 pieces of pipe are laid down end to end in a predetermined pattern.
They get moved by crane 3 or 4 times and go through about 15 or 20 welding stations and coating stations.